Who is online? Okay. So we have, okay, from Mayan is there, Hafiz is there. Okay, Jai, there's another Jai. Okay, I think maybe Hafiz, you want to go first, right, to do a presentation?
Okay, can.
Right. Yeah. So just a little bit of background on Hafiz. Hafiz is my colleague of mine as well. We used to work together in IPv6 quite a lot. So I'm also involved in, I mean, if you check my background, I'm also worked together with him in the, we call it IPv6 forum. Have you heard of IPv6 forum? So that is the reference body here. So I'm currently the global education coordinator for IPv6 forum. So if you want any certification from IPv6 forum, I know you have Cisco and all this thing. So that's a vendor base, Huawei and everyone. But what we do in IPv6 Global Forum, it's a non-vendor based certification. And today our certification, it is basically available everywhere in the world, and quite a number of people already certified on this. We have a, we have what do you call a certification, which is engineer, certified network engineer, certified security engineer, and so programmer. Then also now we're into 5G. So that's why now 5G and IPv6 is closely work together. Later part, we'll have a Prof. Suresh. We're going to talk about 5G and I mean the little bit on SRv6. Are you familiar with SRv6, IPv6 enhanced? I think later Prof. Mayan also going to talk about. This is the new thing in IPv6, okay, enhanced. We call it IPv6 enhanced, where we talk about the advanced features of IPv6 that is used in 5G, right? So 5G later we'll talk about, because in 5G we use software-defined networks. So we use like QoS, quality of service through SRv6 and so on. So today's presentation covers an IPv6, also enhanced IPv6 and security. Little on security, like myself, we are in the area of security. So we will have some updates from China, what is happening in China for IPv6. And I have some speakers. One is coming in from Mauritania, but is not joined yet. So he will be talking about Mauritania. So we have actually now we have done, together with Hafiz, we have done a couple of roadmap to IPv6. So this Mauritania, we were involved in, this is the Sahara, Africa. The Mauritania is a country in Africa. We have done, currently we are doing a work to provide IPv6 strategy for the country, Mauritania. And also we have done for like different countries like Sudan and all these things. So Hafiz is from Sudan. Currently he is in Malaysia, Malaysian Science University. So he just completed his PhD. So he works a lot on IPv6, right, from global environment. Okay, so today he's going to talk about effort to secure global routing, a little bit on the IPv6 part of it as well. Okay, Hafiz, the mic is yours.
Okay, thank you, Dr. Nava. Can you see my slides?
Yeah, can.
Perfect. Okay, thank you. Hello, everyone. And good morning. I'm happy talking to you remotely from here, Penang. I wished if I can talk to you and meet you in person. Okay, so in this presentation is not going to be directly about IPv6, but it will talk about the global routing system, which is including IPv6 somehow. So my outlines include, we'll be talking about brief overview on the routing system and recent statistics. And then also I will talk about the BGP, since the BGP is the primary protocol used in the global routing system, and some initiatives to solve some of these problems. And then accordingly, I will talk about some technologies to enhance and the security in the routing system as well. Specifically, I will talk more about the BGP sec IPv6 extension and deployment issues, and what research opportunities can be done in that area. So right now, as of 27th of January 2024, we have more than 70,000 network advertised and working in the internet right now. And we have IPv6 and IPv4 together, more than 1 million prefixes in the global routing table. And that's a really huge number of connected network in the internet. And this network, as you know, is connected to each other. Primarily, it uses BGP, and BGP is the main protocol that's used in the global routing system, and to share the routing information between networks in a session known as peer. I think most of you are familiar with these jargons and terminologies. So also, as you know, BGP, when it was designed for the first time, it was not it was designed without built-in security mechanisms, and it was based on trust. And whatever two networks decide to have in between, they can configure it as they wish. So accordingly, we have seen some security issues since the network grows, and we have a lot of connected networks right now. And then accordingly, we can see a lot of issues due to misconfiguration, or maybe intentionally sometimes, and so on. Some of these issues is prefix hijacking, and prefix hijacking simply when a network try to advertise someone else's network prefixes, exactly like what was happened in 2008, a long time ago, by Pakistani Telecom, when they announced YouTube prefixes in order to block YouTube for some reason in the country. But end up their upstream provider, which is BCC, advertised that announcement, and then accordingly it caused a kind of DOS, and that's due to the hijacking of the YouTube prefixes. And for sometimes around 2 hours, YouTube was not accessible in the whole area, and due to this simple configuration happened by the engineers in Pakistani Telecom. Again, also one of the problems also in the BGP is the route leaks, and that's always due to inappropriate filtration happen in the session, and that when one of the networks leaks the traffic, leaks one of the advertisement, and then can lead to DOS, or can lead to traffic interception. Address spoofing, that's common, not necessarily with BGP, but it causes a kind of distributed denial of service due to the amplification attack. So when we look at the BGP, how it works, there's no at the beginning, there's no any specific policy or norms between networks to decide how they advertise the information and share the routing information in between. And since we observe all of these problems, and we find out we have to have specific norms, and we have to have kind of collaboration with all stakeholders, with all networks, since the internet is a network of networks. Therefore, you cannot solve the problem. You cannot solve the problem in your network and keep the problem in the other network to allow the attack to happen. So accordingly, there's initiatives led by the Internet Society called Mutually Agreed Norms for Routing Security. It is a global initiative, mainly is to secure the global routing system and guarantee a kind of resiliency in the internet infrastructure, since the internet infrastructure become more critical recently, since we depend on it in everything actually in our life, payment, booking, doing conferences like this, and so on. So Manas, they came out with 4 main actions, and the 4 main actions is actually Manas does not provide new technology. It uses the existing technology, but in an organized way. So it is consist of filtering, and filtering is known. What's filtering? It's just to filter what is not supposed to be advertised. And anti-spoofing, there's a lot of anti-spoofing techniques can be used and properly, and it is better definitely to enable anti-spoofing techniques when it is closer to the source, to the potential source of spoofing. Coordination is a matter of sharing the necessary information between networks operators in order to be communicated in case there is an incident. And there's a lot of systems for that purpose can be used. Global validation. Global validation, actually, it utilizes techniques or technology like Internet Routing Registry database or RBKI. RBKI is actually a cryptographical model. It provides a cryptographical model to provide origin validation. So when we look at the Manas, the main action readiness is still we have very good progress in the filtering, but not yet in the spoofing and coordination. So specifically for the global validation, there's techniques, as I mentioned, like IRR, which is the Internet Routing Registries. It is simply publicly available database, carries information about the route information about what your network is about, to how your network advertise the prefixes and so on. And normally each RIR has their own IRR services free. On the other hand, public resource public key infrastructure, or RPKI, it provide cryptographically verifiable the legitimacy of the announcement. So everybody in the internet will be able to verify whether this prefix is actually belong to that network or no, since the RPKI provide a way to validate the originality and the prefix. So which means attacker's network will not be able to advertise another network or the victim network on behalf of the victim network. It can be detected if RBKI in place. It looks RBKI is lagging globally deployment, and it is below 50%, while the unknown prefixes in internet is about 51%. Unknown, it means there's prefixes but unsigned yet. There's no rules for it. Again, since the validation and filtering, anti-spoofing, coordination, validation is not enough. Even with RBKI in place is not enough. Therefore, we have to have another technology to protect the path, the BGP advertisement path, since the RBKI can provide a way to validate the originality, but there's no way to provide to verify the path, the advertisement path. So BGP-SEC is a technology to do that, and it is primarily provide a way to validate the BGP path, and it introduces a new attribute called BGP-SEC path, and this attribute will be carried in the update message, in the BGP update message. So when you look at the RBKI in place, but there is no AS pass, that means the attacker can simply advertise the victim prefix with the correct AS number, which means the advertisement will be valid, even with RBKI validation. So when you validate the announcement in the RBKI, it will be valid. But the network that advertise or send this announcement is not authorized to do so. So accordingly, the attackers can do that and can also send the traffic to black hole or can send the traffic to null. That will cause attack on availability and cause those attacks. And also can manipulate the content, like look at the prefix, what is the prefix provide, what kind of service is running in that particular prefix. Think about routing server, for example, the root server, the DNS root server. So the attacker can simply advertise the root server prefixes and then advertise it with the correct S number, but manipulate the replies that coming from the DNS. And then accordingly, the DNS will start sending, manipulated replies. That's an example of the attack that can happen with RBKI in place. So this will open a room to very sophisticated attacks. Definitely not everybody can do it, all the networks. But that also can be used on what is known as cyber warfare. So what are the challenges in BGP-SEC? It looks fine. It looks, it achieved the goal and it can provide a way to validate the pass. Why not we just use it? There is challenges. So what's the challenges? What are the deployment issues with BGP-SEC? First of all, there's a problem with the key management since the way it works is actually, maybe it needs more time to explain how it works with BGP-SEC. But even key management, it can be automated somehow, although it adds a kind of complexity in the protocol, in the extension, how it works. But the most important part in the BGP is the resource consumption. It consumes too much overhead. It causes a lot of high overhead on the CPU, consume memory, and so on, since it uses a cryptographical method to perform the validation and signing the resources. So an evaluation and optimization efforts being done for the BGP-SEC, and the scholar here performed a kind of evaluation of the existing methods or existing algorithms that introduced to optimize the BGP-SEC. Since BGP-SEC is a good choice for us to protect the pass, but it has really big issue with the resource consumption. So the researcher here compared the unoptimized and then compared two methods of optimization. The first method is cache common segments, and basically the cache common segments, the router will look at the cache. If the update something different from what we have in the cache, then it will perform the validation and verify the advertisement, and otherwise it will do nothing. That saves some time. That will save time for verification. Another method, we call it best path only, PPO optimization, and this is simply, it looks at the best path, and if there is any changes in the advertisement in the best path, then it will perform the verification, otherwise it won't. So when we looked at the unoptimized in the experiment here, and unoptimized processing, it can go up to 50 minutes. It can go up to 50 minutes to verify 5 beers only, 5 A's in the past. That's really a long time. And I don't think there's a network will be waiting for 1 hour almost to verify only 5 beers. The advertisement, the passes will keep changing with the changes in the network very fast. So we cannot wait for 50 minutes. But it looks PPO achieve good optimization, but it's still considered high, since the time here closer to 10 minutes, and 10 minutes is quite long time. So this is open actually a room and opportunities for research to be conducted, considering also the security of the proposed algorithm. For those who are interested to play with the software and try to perform and build his your own lab, you can use OpenBGB. OpenBGBD is a daemon application based on PSD, and that's all. Thank you. If there's any questions.
Hello.
Yes.
Thank you, Dr. Hafiz.
Yes.
Is there any question to Dr. Hafiz? Anything you want to know? So this, can you give some statistic on these issues related to this BGP SAC and related to IPv6? You know, what are the issues?
Well, the BGP issues is not specifically for IPv4, IPv6. It is actually for both. So there's no difference in the attack. If the attacker managed to hijack the prefix, it hijacked the prefix regardless whether it is IPv4 or IPv6. So, but the main issue here, this is not like a simple attack that can happen for one company or for a small company or for even one university. It can affect the state level. It can affect also the regional level, like what was happening in the Pakistan telecom misconfiguration. So it's not something simple. It can lock out the whole country or can lock out and affect the internet in a regional base. And that's the significance of having such technology. And we study this technology and try to enhance it and make it proper for the normal use, simple use. Because right now, as you see, it require really long time to perform a symbol verification for one single prefixes in 5 bits, for example, as you see here in this statistic.
So, okay, good. But so there is no significant difference between IPv4 and IPv6 when it comes to this. There's no significant difference.
No difference. Prefix is prefix in the BGP because BGP is just provide information, share information between the networks.
Okay, good. Is there any question to Dr. Hafiz? Anything you want to know? Any questions you want to ask? We have new guys that's joined. Maybe you just want to introduce yourself, probably, just to get to know. Yes.
Thank you. I am Makito from APNIC. APNIC is the organization that distributes the IP address in Asia Pacific region.
Okay.
And I am a technical trainer in APNIC.
Okay, nice to meet you from APNIC guys here. Okay, right. They do a lot of training. Yeah. What about yourself, sir? Just to introduce yourself quickly.
Yeah.
Your name, where's your organization, which country you're from?
Yeah, I'm Osamu Akashi of NII Japan. I am very interested with deployment strategies. So it was a long history of IPv6,
Yeah.
but there are not so advanced deployment in the actual entrance. So
Okay.
what is I think the most important problem is here. I think.
Okay. All right. Nice meeting. So do you know Goto-san, Prof. Goto?
Waseda University?
Yeah.
Yeah, I know. I know.
Okay. You know him, huh?
Yeah.
So he's one of the earlier of APNIC. He's a founder of APNICs, if you're not sure. So we work very closely. I mean, get to know him quite long. You know, Goto, I don't know whether he's this time around, he's very old already, I think. So he's one of the earliest pioneers of APNIC and board. He's in the board as well. And we got another board member here from APNIC, Prof. Mayan. He used to be the board of APNIC as well. So how's Paul? Okay. Paul Wilson. He's still the Secretary General, whatever you call. So you call him Secretary General. Okay, good. Nice meeting you, sir. Good. So you want to talk about deployment. Eh? We can discuss about it. I think there's something very interesting that we're going to talk about this morning. This is SRv6, we call it IPv6 enhanced. Are you familiar with IPv6 enhanced?
No, it's not.
You're not exposed to that, eh? How many of you? Oh, we got another new gentleman here. All right. Okay. So how many of you exposed to IPv6 enhanced? Not. So we're going to talk about it as well. Hi. Nice meeting you. Okay. What about the next gentleman?
Nice to meet you. I'm Shigeru Shitani from China, Japan.
Oh, okay.
I'm interested in IPv6 and 5G technologies.
Okay.
Thank you for nice presentation.
Okay. Okay. Thank you. So we have a new gentleman here. Okay. Another person here. Yeah. Yeah. You can introduce yourself.
Yeah, my name is Philippe Gerard. I'm from Nokia.
Oh, Nokia.
So I a bit familiar with, but not necessarily the expert. So I thought that I joined the session. So pleasure
Yeah.
to you. Thank you.
Thank you. Thank you, Smith. Good to see you. Are you based out of where? Is it Asia Pacific or you are? South Korea. Okay, okay. We are here. Another one more person. Excuse me. Another one more person. Good to get to know everyone. Yeah. We're going to talk about Siemens, Nokia Siemens later in my session, or talking about 5G core. I'm going to talk about the case study from you, copy from yours. Not copy, just to share, collaborate. We're going to talk about the challenges in 5G. Okay, what about yourself, sir?
Assalamualaikum and good morning. My name is Wan Azli from University Malaysia Kelantan, Malaysia.
From Malaysia lah.
Malaysia.
Okay, nice to meet you. University Malaysia Kelantan,
Kelantan,
UMK.
UMK.
Okay, good. Nice to meet you. First time coming APAN or been here
First time.
First time, eh?
First time.
Okay, are you exposed to IPv6?
I'm not familiar on IPv6, but until now we have IPv4.
Before
I'm
only.
way forward for IPv6. This
Yeah.
is for me this good platform lah.
Yeah. I mean, we can talk. I'm from Malaysia as well.
Thank you.
Okay, nice meeting you. Good to see you. Thank you. All right. Yeah, please ask more questions so that the session will be interesting. Okay, just to get to know.
Yeah, just from the presentation, I'm just curious because the speaker mentioned that BGP have been hijacked, like prefix hijacked 2008, and I look at the IFC, you have that prefix validation since 2017 it's become IFC. And from the presentation, I'm just curious because it seemed to us that we have quite a big problem of the validation process, have quite long overhead delay. So what is really being implemented in the real life? I mean, that what is the current implementation? Is it really adopted that, BGP prefix validation, and how we overcome that delay overhead to validate that kind of prefix at the moment? Since you mentioned that we probably take like almost 1 hour, like for and another kind of algorithm we take like 10 minutes, like that, I think quite too long. So how the current deployment can be implemented in terms of prefix validation for the BGP at the moment, please?
Yeah.
Okay. Yeah,
Okay.
let me share my screen. Yeah, so the validation is actually for the BGP path. Since the prefix origination can be done with the RPKI, and RPKI has no problem with the validation. You can have like a small server with maybe 2 GB RAM and dual core, any processor dual core. You can run your own BGP. There's quite a number of open source, like Rootinator, for example. You can use that to have your own validating server for the RPKI if you're looking for origin validation. But the issues here with the path validation and the technology that we have to perform path validation is the BGP-SEC extension, which is the extension added to the BGP. And because the overhead, it is actually because of the nature of the technology itself, since it uses a cryptographical model to perform the validation. if you look at the way here, how it works here, and you can see that the first router, which is with the AS1, it will sign the prefix with its own AS number and then add the next AS number, and then carry this information as a BGP update to the next router. Then the next router will sign again the whole content, including the signature coming from the previous router, then add its own AS number, and then add the next AS number, and so on. So whenever the passes grow, it requires more computational power to perform to sign the prefixes, and then vice versa as well. So this is consumed really long time, as you mentioned as well, and therefore there's efforts to optimize the BGP-sec specifically. And what I showed here is actually 2 methods only, but probably they may have different methods of optimization. And even the BPO here, it looks very good, achieved very good time, but it's still quite a long time. For 10 minutes is quite a long time, because the network in 10 minutes can keep changing many times. Like within 10 minutes, the network can change maybe 10 times. So even PPO still not enough for something can be used for the for the network. So still we need to find a way to optimize it. There's actually another effort happen in the hardware itself to introduce specific hardware to achieve this process, the cryptographical process. I hope I answer your question.
So actually BGP-sec hasn't been implemented, right?
No, there's implementation right now. You can download it and you can use it. There's implementation right now. There's Kevin?
I mean the deployment at the real router.
Right now, it is very limited. The deployment is really limited and mostly for observation and research, where very few network are implemented, and also they implemented in a very limited part of the network. Yeah, that I've heard that AT&T and have implemented with another operator, but internally in between to look at how these things can be done. Yeah, but there's no like a big scale implementation happen in the internet right now.
Okay, great. It's a good topic because let's talk about BGP, the core topic. There's a lot of research work is going on. When it comes from security point of view, all of us, come to IPv6, when we teach about IPv6, we always talk about 5 ways how you get IP address. In IPv4, we got 3 ways normally. That's what I mean. You got manual, you got random, and you got DSP before. In IPv6, we got 5 ways of doing it, okay, where the SLAC comes in, and we got DHCP v6. In first of deployment, this was a question that I've been asking for a long time. We've been always talking about, we have SLAC, but honestly speaking, if you talk about addressing the 5 ways, you have manual. Obviously, manual is not an easy way because you need to figure out. Okay, we use automator, we call it SLAC, state auto enter configuration. It's a good feature of IPv6, but personally feeling, over the last 15-20 years that we are talking about IPv6 implementation, very few people implement SLAC. Even though there's a lot of, in fact, my PhD work is in SLAC and recovering, come out with a router discovery, how to do a secure router discovery. We talk about it, but not much implementation. So the realistic part of it, a lot of people, IPv6, I think Prof. Mayan would agree. I don't know, Prof. Mayan later could share also some light on what is they done in China, because China is one of the leading countries that actually deploy IPv6. So we see DHCP v6 is the main way forward. So I think, I don't know, I think your organization, do you implement DHCP v6 or you're using any other implementation? I think send, I don't think so you implemented send. Most of the implementation in IPv6 that we are talking about today we are talking about SEN, secure neighbor discovery, right? Then secure neighbor discovery, it's not a right way to implement because it's huge protocol. If you go in, so not suitable. You know, you want to get IP address, it takes four minutes to get IP address, the lowest encryption. If it's highest encryption, you even can go up to 1 hour. So it's not suitable. So obviously, in terms of real world deployment, we talk about DHCP v6. So DHCP v6 also got a lot of problem. Now we are talking about DHCP-SEC. Like some of my students now, they are doing a lot of research work in DHCP v6, where attacks on DHCP v6. Okay, because we cannot rely on DHCP. So we got DHCP v6 SEC. You know, so even BGP that matter, like what Hafiz was sharing. Hafiz, are you free?
Yes.
Yeah, okay. So we were talking about BGP SEC. It's something that a lot of discussion going on. Of course, RPKI is there. I mean, like Hafiz is in favor of RPKI. I think we got APAN guys. Yeah, we are talking about RPKI, but the other school of thought said we do not want RPKI. You know, some of you can see later if you talk to Prof. Suresh, he is not in favor of RPKI. But there's a reason behind it. So a lot of things. So coming back to BGP SEC, which is very important because on the network part, this BGP part, security is important. So some of these solutions are available, but not implemented because IPv6, even though it's existent since 1999, you know, that when RFC was wrote, until today, security is the biggest challenge because now getting people to go to IPv6 is the biggest challenge. You know, so now only we can see, like if you see today in global statistic, India, China is a large IPv6 implementation, and we are talking about 60 to 70%. Like Malaysia, we also about 60%. I'm not sure about Thailand. How much is the percentage? I didn't check the status. What is the percentage? Any idea? Anyone got any idea? How much? Huh? So like Malaysia, we started a lot. We've been pushing IPv6. So today, Malaysia, we almost 60 to 70% of our traffic, IPv6 traffic. Take a note, 2025, US got to stop supporting IPv6, IPv4 on their network, not IPv6, IPv4 on their network. 2025, this is the strict from the US government itself, right? OMB came out a circular saying by 2025, there won't be any support for IPv4. So not far away, we are just one more year, 2024, 2025. So any equipment that purchased in US, because we always refer back to US, 2025 onwards, we can see IPv4 is dying. Of course, how long is IPv4 will be there? It's $1 million questions. But like in China, later, from Mayan can agree, I see the Chinese government has came out with a direction saying by 2030, total cutoff IPv4. So, and we are dealing with these challenges now, deployment. Of course, Japan already done very long ago. And I mean, one thing salute for Japan, they've done, because I've worked with Japan quite a lot. In fact, they work IPv6 only, single stack. You know, the smart meters in Japan only works in IPv6. You know, if you're talking about smart meters, is a dangerous, you know, it's a critical network, you know. So in Japan, it runs on single stack. I don't know whether you know Mazaki, Prof. Mazaki, is Professor Mazaki from Keio University. Yeah, you know him, huh? So I was involved with him also on the project. So like Japan already know, you know, the security issues has been addressed, and there's quite a view. I mean, this time, probably next meeting, I'll get Mazaki to come and talk about it because he have implemented single stack. Right? So all of us now still talking about IPv4, but IPv4 is the dawn technology. Right? We need to start thinking about IPv6 only. This is native, so 2025. And the China later you can hear from Prof. Mayan that 2030, nothing going to happen, you know, all will be on IPv6. Okay, Thank you so much, Hafiz.
Thank you.
Yeah, please.
Just one short question. Like we are talking about the solution to protect like prefix hijacking,
Yeah.
right? But I'm wondering that when we have got hijacked, well, are there any solution to like mitigate the issue? For example, the presenter mentioned about prefix hijacking on YouTube traffic. Like, how did YouTube like dealing with this kind of problem?
Yeah, Hafiz. Yeah, you got more question now.
Yeah, very good question. Actually, there's no way. You have to contact those who hijack the prefix and then ask them to stop advertisement. Or otherwise, we can look at their own upstream provider to filter out the problematic announcement. That's the only way. Therefore, the initiative suggests to have a way of coordination. So whenever the incidents happen, we must have a way to communicate with those who are involved. And then we ask them, look at your network, you have this problem, then accordingly, they will take the appropriate action. But if you looked at it as a technology or techniques to stop the hijack, basically, we have to implement actually massively BGP-SEC, we have to implement RBKIs, and RBKI is going very well, but BGP-SEC is still, we need to look at how we can implement it and optimize it actually. But for if there is a hijack happen right now, we have to contact the operator. That's the only way. I'll let them take the action to stop the hijack.
I think at the moment that is the only way to look at it, because we need to inform the APNIC or whoever hijack. You know that if you're familiar with APNIC, you know the issue in APNIC. You're all familiar with the case in APNIC where the IP is been, you know, there was a case where until APNIC has been banned, you know, the court has said you cannot operate. This scenario where the Chinese company operating in Africa, they took the prefix, and the landing point of this routing is in China. Do you understand or not? So the prefix is belong to APNIC, but the routing is done in China. And this is when APNIC found out this issue. They actually talked at that time. This is talk about organizational internet governance issue. You know what happened? There was no ruling. There was no law says that you cannot bring that IP to the other place. You cannot land. Like last time I had an experience in Thailand. I used to work with Thaicom. You know, I was working for a company called Becom. We provide internet connectivity in Malaysia, landing in Thailand. So the IPs that we are using is Thai IPs. We are not using Malaysian IPs. So we are landing in Thailand. Of course, that time APNIC, this issue is an issue. But the problem when APNIC is take action against them, they went to the court. And the Chinese company not in fault as well, because there's no written. And APNIC say you cannot do that. This issue because it's run out of IPv4. Because IPv4 has become commodity now. You know, today you can buy at one IP at 50 USD. And there was a lot of, if you need IPv4, but let's forget about IPv4. That's what we are talking about. If that issue was been addressed, if it is IPv6, I think don't care. We got millions of IP. So it wouldn't be any problem. So these are the issues. So a lot of governance issues and things. So we would not know. So security, it's a big area of discussion. And obviously, a lot of researchers now working on like IPv, like Hafiz is working on a lot of BGP, RPKI. There's a good thing. There's a good pro and cons, but security is still a big question mark. You know, it will be ongoing problem. You know, IPv4 we have enough security issues. In IPv6 also equally. When we roll out only, we know the problems. Okay, so that's we can move on. Okay, sorry. Yeah, good. So can you just use the mic?
What is your view or thinking on Flex algorithm? on flex algo, segment routing.
Flex algorithm, I'm not quite flex. Are you talking about SRv6 or enhance? Are you talking about that?
No, just routing protocol.
Okay, I have no exposure on that. Afis, do you have any idea on that? Algorithm, you know, flex.
Yeah, flex algo basically segment routing. So usually for now we'll go to a paradigm where the origin is deciding, the destination path. In IPMPLS now you get all these problems like you mentioned.
Yes, exactly.
They have stack the labels, and like sometimes we lose a little bit track of where everything is going, right? And in segment routing we are trying to from the origin point of view define the segment, right? And then so you get OSPF and ISF as your routing protocol, and now you've got flex algo that tells you like within the routing, this is like the path that I want to choose.
Okay,
right? So
good. Okay, this is something that I'm also exploring now in big way. Now teaching SDN, Kubernetes and all this SRv6. We are now trying to teach and try to explore because IFIT and later part we will talk about it. I think having multiple algorithm to solve, it's a good way forward. I mean, that's my opinion, because there's no one single fit for all the solution. So we have various solutions for various problems. Like one interesting issue, like my university now, they used to be in Google. They were using Google as a platform. Suddenly they announced now going to Microsoft 365. You understand now? So from the security point of view, security point of view, using single platform to do this solution, you cannot do because you are actually tied into one particular. So that's my opinion. Of course, if I have chance to further explore what you are talking about, now we are trying to move that. I think logic thinking, from my point of view, I don't have much detailed knowledge on this now. Probably logically having multiple algorithms to solve these problems, MPLS, like you're talking about ISS. So different solution for different scenarios will be a good option. So are you working on that now?
Yeah, I mean that is a hot topic, so I thought of bringing up, but maybe we could follow up.
We can talk about it later. Okay,
we're here, right?
All right, yeah. Okay, we have another presentation from Prof. Maya. Okay, thank you. I think we'll stop the question now. Let's hear out from Prof. Mayan. Prof. Mayan, are you there? Prof?
Yes.
Okay.
Yes.
It was a good deal of discussion. Okay, this is Prof. Mayan. I used to be our co-chair for IPv6 working group for so long. We miss you, Prof. Mayan. Okay, he has been IPv6. He was doing a lot of work in CERNET. He used to be UPT, now officially retired, semi-retired, I will call it, but still active.
Yes.
Okay, so he's going to talk about updates from IPv6 activities in China. So the mic is yours. Please carry on.
Okay, so really nice to meet all of you online. It's pity I cannot came here to attend the meeting in person, but anyway, the previous discussion is quite fruitful, and really it triggers our discussion and the collaboration in the IPv6 activities in our working group. My report on the latest development in my university in CERNET, China Education Network, it's called CERNET, China Education Research Network. So in abbreviation, we call it CERNET. Some of the topics it covers today is the 30 years of internet in China. And now it's 2024. We're starting our internet connection to the global internet in back to 1994. So it's a time flying, 30 years past. We do a lot of IPv4 at the very beginning in 1994 and early 20s. Now we come to IPv6 age. So IPv6 deployment statistics, I will give you some of the figures to know how the development has been taking on in all the sectors of the society. Government side, university side, industry side, service provider side, and show you some of the figures. And we also building our infrastructure more intensively. Zhong Huili is on site in the meeting. So if you have more discussion with him, you can get more latest information. He will also give a talk tomorrow about operation of CERNET, the CERNET 2, and some of the research and applications and training activities. So you see, we starting officially with global internet in 1994. Now it's 30 years. 30 years passed. A lot of things happened. So without internet, the society cannot be running even. So even the taxi drivers and the bicycles, ever a lot of utilities, even during the pandemic happens, people at home studying, working, just relying on internet. So internet really plays so important roles in our daily lives, in our modern societies, but also triggers a lot of problems. Some of the headaches, privacy leaks, and some of the hacker attacks to our operation of the network. So it's a, but anyway, the days are happening, days are migrating. So we have to rely on our digital technologies. So digital society is our future. We will have to train our next generation young people know about the networking, about the data, about the artificial intelligence, relying on our digital technologies, and use the best. You make best use of the technology, and avoid and block and really cut those harmful actions on our networks, just like a previous talk about the BGPs. So BGP is in the network layer, and in the application layer, there are also some of the threats and also some of the benefits. So back to talk about IPv6 deployment. So this is the data statistics given by the Internet Society. So you see globally, a lot of economies, countries, and places deploy IPv6 so intensively. China, as I remember, back to 2018, something 3 years earlier, IPv6 really going so fast. At that time, 3 years later, 3 years previously, we do a lot of intensive work at promoting the IPv6 from a government side, from a university side, from an industry side. Now the traffic, Dr. Navar also mentioned the percentage of the IPv6 traffic. Now to the static data released by the Internet Society, over 50% of traffic now in China come to IPv6. So we rely on IPv6 quite intensively nowadays. Last year, so now we're in 2024. The last year, internet user count to over 1 billion in China, and among those users, 70% of users now enjoy the activities, connectivities of IPv6. So IPv6 user count to over 0.76 billion of total internet user in China. So the number is still increasing. More penetrations in all sectors, in home networking, in the industry, in the government, in the enterprises. People more and more using IPv6 nowadays. The operator by statistics by operators. This also the figure provided by the Internet Society. You see, the first one ranking is CNGI, China Next Generation Internet. So this is the project initiated by the universities, leading by Tsinghua University. My university also one member of the CERNET 2 of this organization. Our backbone is 100% of pure V6 traffic running. And then more others, say from Canada, from India, from China, Zhonghua Telecom from Taiwan, and T-Mobile, all those providers. China Unicom, China Telecom, China Mobile, and those are provided in China. They also promoting IPv6 quite intensively. Some of the traffic already come to over 50%. Active users as we have previously mentioned, 67 million, 70% of total user enjoy IPv6 connectivities. And more applications, top 100 apps, apps in our mobile phones, over 99% support IPv6 nowadays. So really people pay much attention to supporting the IPv6 connectivities and enjoy the benefits for security, for the quality of services. Regardless of the mobile services, fixed line phone still lag behind. Only 16% of the home broadband router supporting V6, because those household users, they reluctant to replace their already installed home broadband routers. So we still have a lot of work to do to promoting V6 and then replace those old devices, old broadband home routers. So this is the development. And also government makes statistics. Last year, June, May and June last year, more than 50% of traffic on IPv6 nowadays in the mobile networks. So I've traveled to a lot of places in Tibetan, in Xinjiang Autonomous Region, in the northwestern part, in the southern part, all the provinces turn on IPv6s. So people can enjoy the connectivity everywhere, and all the providers supporting V6. And IPv6 related research papers worldwide, you can see during the year 2000, not much, less than 10 or 15 worldwide. But nowadays, in the last year, 2022, over nearly 1,000 research papers published related to IPv6, to the security issues, quality of service issues, IPv6 enhanced features, and routing issues and the management issues. A lot of research papers published worldwide, and a lot of Chinese students, professors, and technical engineers working on IPv6 nowadays. Back to our CERNET connectivities. So CERNET is a academic network, education research networks. We connectivity reach to the global networks, to the Internet 2 in America, GEON in Europe, and APAN in our Asia Pacific area, and many others. All the worldwide connectivity established, ranking from 10 giga to 100 giga. And domestically, we're also connecting to all the major service providers in China, commercial service provider and academic networks. For example, the CST, China Science and Technology Network. So it's operated by Academy of Sciences in China and many others. So we enjoy the high connectivity to reach all the information by using IPv6 in China and worldwide. The CERNET update, CERNET network update, we operate the background optical fiber networks over 30,000 kilometers all over China, from northern part, southern part, western, eastern part. So by using these optical fiber networks, we're building our DWDM network. It's a 40 channel, each with the 100 giga DWDM networks. So by using this DWDM optical network fiber, we're building 3 IP networks. One is the CERNET, the very beginning back to 1994. It's called the China Education Network, CERNET. It's an IPv4 at the very beginning, now also turned on IPv6. But CERNET 2 is a research-oriented network connecting all those major universities doing the research and education in higher education in China. So connecting 36 cities and 41 gigapops in all over China. Now we are building the third one. It's called FITI, future internet technology infrastructure. So this backbone is also a pure V6 or IPv6 driven networks connecting the 35 cities in China. We already make an evaluation of the first round of building of this infrastructure. Starting from this year, 2024, we will install more and more experiment on the fitting infrastructure. Future internet research activity will be conducted in the FITI network. Talk about the Ethernet 2. Back to last year, you see this is the topology. Major gigapops running 100 giga, and some of the remote provinces running 10 giga. Less students and less experiment be conducted, but still they can enjoy the connectivity with all the major universities, domestic and overseas. In total, we have 2,232 educational institutions getting connected with our network. So people can share information, doing research and education works by using this Ethernet 2 infrastructure. Active IPv6 users come to 17 millions by using this network. So it's a really very large network. And Zhonghui is one of the operator chief engineer of this network. So if you have a more detailed question about operation, troubleshooting, security, tracking, and quality of services, you can contact him. He's on site. And Ethernet 2 backbone traffic, we make some of the statistics. You see, during the last few years, the traffic of IPv6 is really soaring as it comes to nearly 1 terabytes. So many people enjoy the connectivity, doing research and video conferencing and research activities. A lot of experiments have been conducted using this Ethernet 2 infrastructure. More and more member universities increasing their deployment, not only the website, but also their daily operations and student uploading and downloading courseware and share their research results by using the IPv6 nowadays. This is the infrastructure called FITI, Future Internet Technology Infrastructure. This is one of the important part of the China's first major national science and technology infrastructure project, and in the field of future internet test facility. So not only academic people focus on the research, but also some industry people, engineers also doing the work, focusing on the future internet technologies. Our FITI is one of the efforts. So the FITI is built by 40 universities, leading by Tsinghua University. And Professor Wu Jianping, he's the chief responsible people and make design and operation and building the research activities. Relying on pure IPv6 technology, covering the major provinces and autonomous regions in China. So you see from Xinjiang, from Lhasa, from major universities connecting to our network, doing the research activities, aiming to providing and leading an open testing environment for the researchers. Last year, 2023, we starting very high speed, 1.2 terabit per second high speed interconnection link from Beijing to Wuhan to Guangzhou. One router port operate at 1.2 terabits per second high speed. So this is a really non-commercial product at this moment. It's a really trial. It's a test, testing the capability of the devices, the technology, the operations, and the management issues. So we're building this infrastructure with all our FITI projects. So this one already successfully operated. You can see the traffic from Beijing to Wuhan city over 1,000 kilometers, and another segment from Wuhan to Guangzhou is another nearly 1,000 kilometers long. So in total, nearly 3,000 kilometers long backbone traffic, 1.2 terabit per second high-speed trunk. It's a trial. It's very successful. And then this is the statistics data by our member universities. You see, if you are interested in, you can click on the link ipv6c.cngi.edu.cn. You can see all the statistics major universities. The first one is my university, and then Tsinghua and Peking University, the major universities in China. The website supporting IPv6, DNS supporting IPv6, and input and output traffic are showing in real time. You can see a lot of detailed information. So we're still improving our infrastructure and building more better testing environment for our professors and students. Talk about the IPv6, we had to say something about IPv6 plus. Normally, we enjoy the connectivity, the vast IP address space. We can use a huge size of IPv6 address. These are the benefits providing by IPv6, but we still not sufficient features. We need more features. So based on IPv6, more enhanced features provided by the IPv6 plus. These are the activities conducted in IETF in our research and industry community. Research activities very, very actively happen. So if you are interested in, please click the IETF website to see a lot of drafts, a lot of discussions to enhance the features. For example, automation and programmability, secondary routings to have our traffic be managed and automatically processed, and to avoid the traffic burdens and secure the path and more manageable path to ensure the cost of services and deterministic latency. For example, normally by using IP network, it's just based on the best effort. People know about this, but more and more industry people rely on IP networks. So they put the desire how to let our packet transfer from one place to another place, but with a fixed deterministic delay without the time varying. So this kind of research is very intensively conducted in IETF, in IEEE. So this is one feature provided by IPv6 plus. Now, vast connectivity for scalability, more and more devices, not only the PCs, personal computers, and mobile phones, but more and more devices, for example, IoT, Internet of Things. So many devices getting onto the networks, how to manage them, and how to assign IP addresses. DHCP or Slack or some other new mechanism be considered. So this kind of features provided by IPv6 plus, and the security features, ultra broadband, and ultra low time delay. Those kind of features really heavily discussed in IETF activity. So in our university, in our research communities, people really put a lot of energy in doing the research activities. So really encouraging our people have more collaboration, more discussion on these topics. In more detail, for example, the SR video segment routing version v6, network slicing, IFIT for the traffic monitoring, for BRv6 for used for the group routing, the multicasting, have a better configuration features and easy to providing the services. And APN, application aware networking, not only the IP layer aware of quality of service, but collaborating with the application layer, how to make the application aware about the network situations, the time delays and the packet loss and the quality of services. So providing the better quality of services, those kind of features are provided by IPv6+. Many IT have a RFC draft under discussion. So really encouraging people reading those drafts and to know the latest development. And the fields of application may also including manufacturers, smart transportations, and smart cities, and all those kind of fields. So IPv6+ will be the next round of focused research activities in our community. Really trigger our imagination to build innovative ideas to make a better network capabilities. Some of the IPv6 education-related applications in our university community, for example, application on IPv6-based continuing education teaching resource sharing, improving the measurement of streaming media transmission in education based on IPv6, and research on intelligent evaluation of computer programming courses based on IPv6 teaching systems, etc. I won't list them one by one, but you see a lot of people focus on the research by using the advantage of IPv6. So it's a very active research area in China. IPv6 network-based university management information systems. So this is a very active activities. And we also initiate the competitions for students to innovate ideas be implemented. So the first round IPv6 technology application innovation competition was organized this year. Last year, we organized in 4 tracks: the industry track, and the auxiliary government track, and the humanity track, and the science education track. Our universities, many universities enjoying the last track, science and education track, focus on the key core technology of next generation internet in education sector, focusing on 3 major areas: infrastructure, by using public internet, 3G and 5G, and campus networks, content delivery networks, and data centers. A lot of IPv6 innovative ideas being put forward. And the security issues, innovative v4 IPv6 routings, and signature identifications, certifications, and a lot of issues related with the security issues and applications. So by using IPv6 features, a lot of students really very good ideas have been put forward. Also, we promoting the innovative projects and the competitions. The next generation internet technology innovation projects was held. Over 370 teams from universities and 680 projects joined the research. So a lot of work has been done. Those one could be run on dual stack or on pure single IPv6 single stack networks. And a lot of students put their patents applied to the authority, and 1,000 research papers have been published. In the next generation internet technology innovation competition, as I mentioned last year, total 76 awards were selected in the science and education track, as we have mentioned, the 4th track. And 24 projects won awards in the final, and over 300 intellectual property have been produced. So it really triggers students to know about IPv6, how to make the best use of IPv6, and a lot of new application areas. My university also won one of the best cases. So government call for collection of IPv6 enabled showcases. They select the 100 projects my university is one of the projects to be selected. So promoting the deployment, covering the research, education, deployment, manufacturing, agriculture use of IPv6, and the natural environmental monitoring, and the energies, the natural energy uses of the best resources. Those kind of areas have been selected among those 100 projects. And the standardization activity also one of the major efforts by our member universities. Professor Jianping Wu, he leading his group to leading one subnet working group. This working group have been established in the year 2022. Focus on the security issues, the source address validation within network domain, among domains, and management issues. And some of the RFCs have been published, and more discussion on those drafts. And Professor Xin Li, leading his group, my university also joined in the IPv4 and IPv6 migration technology, the so-called SAVA is the first belong to the subnet working group. But the IVI technology, IPv4 transition to IPv6 technology, it belongs to the second research areas. So some of the RFCs, 6052, 6877, 7050, and many others have been published. So it's one of the major efforts to let the IPv4 world transit to the IPv6 next generation internet. A lot of vendors using these protocols already. For example, Cisco, Huawei, Juniper, and many other vendors, and including Apple and many other application company, apps company also using those kind of technologies to let people enjoy the connectivity, regardless is IPv4 or IPv6. People just clicking, but the protocols can translating the IPv4 to IPv6 or vice versa. This is also international collaborative works. And the training works, we have been conducting a lot of training activities. 3w.ctrack.cn, this is website, it's publicly available. We organize those video clips. Some of the video rather short, 15 minutes, and some of the videos are longer than 1 hour, related to the IPv6 basics, the security issues, the programming and network operations, and IPv6 related topics, design of the campus network, 6LoWPAN for IoT, use of IPv6, and EduRoam services. People can enjoy the connectivity and also certification among roaming, and IPv6 with smart cities and the search engines, a lot of topics. So if you're interested in, you can click in the website to see. But unfortunately, currently, most of these videos are in Chinese, in Mandarin. So this is the training course that we have been conducted in the major provinces in China: Hebei province, Hunan province, Sichuan, Yunnan provinces. A lot of provinces, people enjoy the connectivity using the lab equipment. So people can practicing how to make a configuration, what's the basic idea about IPv6 routing and server provisioning, website, web hosting, those kind of skills have been given by using our training courses. And the training activities for certain members, inviting IPv6 experts from universities, governments, and research institutions and enterprises. So those very expertise expert giving the courses to those students and engineers in university and industries. The training camps organized in many provinces certification have been issued after training courses and examination. Some of the people successfully for the first time, but some of the people had to do the examination for the second time. So people had to make their efforts. So on-site classes and the lab exercises have been conducted. Because time limitation, I will give you very brief information about our IPv6 latest development. Let's working together to build a better internet. Thank you. Any questions?
Thank you, Prof. Mayan.
My pleasure.
It's a
Thank you.
detailed, great information available on the slide. Okay, any questions for Prof. Mayan? I think some of you wanted to know some informations, regarding IPv6 deployment. So you can see quite extensive deployment has been done in China. China is one of the leading nations in IPv6, right? And followed by, can you pass the mic to? Okay.
Hi, I'm Osamu Akashi of NII. My question is this a pure IPv6 network or there are some transformation point between V4 and V6? So I think some V4 domain support required, but is this a pure V6 environment?
Okay. Okay, thank you for the question. At the moment, major universities, they're running dual stack inside the campus. So people enjoy the connectivity by using your applications. For example, if you are nowadays a major operating system OS supporting V6, so most of the devices just running dual stack. We are promoting the dual stack, the single stack, but at the moment there's still trial. Major immersion, most of the environment is IPv6, IPv4, and IPv6 dual stack. As we have mentioned, we running 3 infrastructure. One is Cernet. Cernet is IPv4, and some of the IPv6, not much. But the Cernet 2 is a pure V6 backbone, and a lot of connectivity been carried out. For example, we're using our Cernet 2 connecting to the commercial providers, Tencent and Baidu, those major providers. They using IPv6 connectivity, providing their services. So inside the campus is dual stacked, but the backbone will have a dual stacked and pure V6 IPv Cernet 2. So it's depending on the application. We're promoting V6. So by using the V6, you will have a higher bandwidth and more and more resources, more and more resources. Inside the campus, if some of the resources is IPv6 only, is a single stacked, then we're using our converting devices, say the IVI translator, translate from IPv4 to IPv6 or vice versa. If your service provider providing dual stacked, then it's just depending on your socket connection. So if you making the click using your mouse click or keyboard click, then your application request for the DNS. If a return is IPv6 only, then your connection will be IPv6 traffic. If the feedback is a dual stack, then just depending on your application socket connection, maybe V4 or maybe V6. So it's depending.
Thank you. Can we share this file after this meeting?
Yes.
Slide.
Sure.
Yeah, slide file.
Okay, sure, no problem.
Oh, okay, thank you.
Thank you, my pleasure.
I think, is there any more questions?
Yes, you said the institute get you are mostly dual stack. So institute get 2 connections for IPv6 v4. I mean 2 interfaces, or is it at H level dual stack in Solid?
upstreams at the moment, Cernet providing IPv4 upstream link, and Cernet 2 providing IPv6 uplink. And commercial service provider, at the moment, most of the service provider providing IPv4, but some of service provider, for example, China Telecom and China Mobile, already providing dual stack. So just depending on your agreement with the service provider.
So
if you request IPv6, then service provider will providing you with the commercial IPv6 link. But for Cernet member universities, we providing dual stack, and Cernet 2 is a pure v6, and we really encourage our member university using more and more IPv6 traffic.
So that means each institute campus get 2 connections.
Yes.
What's the reason to have a separate IPv6 backbone other than going to dual stack? I mean,
now I have heard China Telecom, they already implement several provinces using the pure v6 IP single stack pure v6 service to IoT services and on mobile services. So for example, your high quality voice call over mobile phone is a pure v6 service nowadays. And China Mobile also using their VoLTE, voice over LTE service is a pure v6 single stack service.
Is having a separate IPv6 is good with the performance wise and management wise?
Yes, they have a pure v6 backbone running at the supporting infrastructure.
Is it I mean, cost effective in equipment wise? So
major service provider, major router manufacturers, for example, Cisco, Huawei, and those already providing dual stack support on their devices.
Thanks.
You're welcome. Okay, thank you.
Thank you so much. Thanks for your time. So we'll go for a break, then we'll start back at 11. Okay?
Okay.
Thank you. Thank you, Prof. Mayan. You can join us later.
My
Okay,
pleasure.
thank you. Bye.